Welcome back to Math 3. So let's see, that's going to be Math 3, Quarter 1, Week 3. Got it. Look who it is. It's my new puppy. Woo, new puppy. So this is Samson. Nice to meet you guys. Say hi to Samson. Samson's a 10-week-old golden doodle. Woo! Hi guys, it's me. I'm Samson. He's super cute and he's waving to you. Do you have any pets? Yeah. So this week, we're actually going to be learning about, here it is. We're going to be learning about graphing absolute value and solving absolute value equations. And so last week was radicals. Graphing and solving radicals, a bit of graphing review. Awesome. So what I'm going to look at is this classwork one because it kind of reviews last week's and jumps into this week's lesson, which is awesome. So this is a great assignment for kind of getting to know what you already have. I'm going to say goodbye. Goodbye. Oh, what did you say, Samson? Oh, Samson wants to know your favorite pet. Or if you've ever had a pet or if you want a pet. So because you missed our Google Meet, so in there, the fill in the blank is, for this week, do you have a pet? What's your favorite pet? Is it a dog, a cat, is it a turtle, a snake? Hamsters are the best. Or if you ever had a pet, or if you've never had one, but you want one, which one would it be or maybe you don't even want a pet at all, so make one up, like a unicorn. So go ahead and put in there what your favorite animal, or favorite pet is, rather, or maybe domestic animal. Favorite pet! Woo, favorite pet! And we'll say goodbye to Samson for now. Bye, Samson. Yeah. And so he's a golden doodle that's mini, so he's only going to be about 25 pounds. And there's Max. Say hi, Max. I'm a big sleeping dog. And my name is Max, and I'm also a golden doodle, but I'm first generation, so I shed a lot. Okay, so again, this week is going to be, so we did radicals last week, which we got a little bit of matching going on there. And then we'll jump into absolute value, which is pretty awesome. Whoa, graphing absolute value? No, graphing radicals. Let's start with the graphing radicals. And so look at this one. I'm curious about this one because it's upside down, right? And upside down, like 0, 0, over 1, down 1, over 4, down 2. So that would be upside down graphing radical. But look it actually shifted up 2 to begin with. So we're looking for a graph E. We're looking for a negative radical x plus 2. So graph for negative radical x plus 2 would be graph E. Nice. Let's double check. Yep, looking good to me. And if you're not sure, you could go ahead and plug it into Desmos. So you go negative radical x, right? Don't forget right arrow. And then we're going to shift up 2. Woo! There it is. Boom, boom. There's our graph, which is just like graph E. And so cube root is a little bit different. Cube root is like 3 dots in a row, right? Uno, dos, tres. Uno, dos, tres. So that originated from the parent function, -1, 0, 0, and +1, 1. And so we went ahead and shifted to the left 1, 2. So we're looking for a cube root of x. We're looking for a cube root of x with a -2, right? No, that's a -2, so that's a shift left 2. So we're looking for actually right 2. So can we find that cube root of x with a -2, which no, it's left 2, so it means +2. So that's number 1, right? That's number 1. There we go. So again, this one is a left 2, which is actually opposite what you think inside the radical, or the cube root, which is +2. And so number 1 is going to be D. Number 1 is D. There we go. So hopefully that's making sense. Now absolute value, absolute value is like a V, right? Keeps everything positive. And so with absolute value, what we're going to do is we're going to also shift the same, but if it's in the absolute value symbols, you'll go to the right. If it's like a -2 or a -3, or you go to the left. So for example, here's number 2. They want us to come up with the equation. Here we go. Let's take a look. Whoa, it went blue on me. That's crazy. Let's click off of it there. And then let's push new. Cool. So you can kind of see here that this shifted from 0, 0, this shifted to the right 2. So you want to make sure that right 2 is opposite what you think. So not +2, but -2. Nice. So then we look for x minus 2. Here it is. So that's going to be equation 3. Making sense? Making sense? So number 2 is actually going to be, so graph number 2 is going to go with equation 3. So we go to equation 3 and we look for matches with graph 2. Nice. So then let me show you just so you can check your answer. So look, there's an absolute value symbol just above the ABC with an x there. And let's say that we want to go right to, like that graph we just discussed, you put it inside the absolute value. And so negative 2 means right 2. Can you see it? Negative 2 means right 2. And positive 2, can you see it? Means left 2. So it's opposite what you think when it's inside the absolute value symbols. But then it's also the regular, not opposite if it's outside. So plus 3 would mean shift up 3, right? Shift up 3. And then if it's minus 3, then it would be down 3. So the outside of the absolute value just stays the same. So you're going to ace that assignment. This whole assignment you're going to ace, which is super easy. Okay, last but not least is solving absolute value equations. So all you do to solve an absolute value equation is get everything on the other side that's not absolute value. So isolate the absolute value. Then split the equation up into 2 separate equations. Nice, nice. And so you're going to drop the absolute value on both of them. But then on the right side, you're going to change it. So 11 stays positive, and then 11 becomes negative. What? That's crazy. So you're going to solve 2 equations. So you can see here that you minus 7 to the other side, minus 7 to the other side. And so then you get negative 2x. We minus it to the other side. And we got negative 32. Over here, we've got 25. So we minus it, minus that 7 to the other side. So then we have 18. And then divide by negative 2, divided by negative 2. We get x equals negative 9 and 16. And so that's how easy this week is. Woo! Super easy. Super duper easy. So we'll do this first one here together just to show you. So we have 2x plus 3. We're going to drop the absolute value. And we get a positive 5. Then we're going to take 2x plus 3. We're going to set it equal to not a positive 5 this time, but we're going to change the sign. Because absolute value makes everything positive. So we have to account if the original was negative or not, basically. So we'll minus 3 minus 3. And so when we do that, we get 5 minus 3 is 2. So we get 2x is equal to 2. Then over here, we're going to minus 3 minus 3. And instead of 2, this time they're both negative, so that's going to be negative 5. Apples off my tree. You took 3 more. You owe me 8 apples. And then we're going to go ahead and divide by 2. Divide by 2. So we get x equals a negative 4 as one of our solutions. You can plug it back in, make sure it works. And divide by 2. Divide by 2. So then you get x equals 1, which is one of our solutions. So plug them both back in. We get 1. 5 equals 5. Negative 4 in there. Negative 8 plus 3 is negative 5. Absolute value, positive 5. 5 equals 5. So 1 and negative 4. Can you find that? Ooh, careful. It's not that one. It's actually a negative 4. Be careful now. There it is. Bada bing, bada bang, bada boom. Thanks for watching. Peace out. And bye for now. Thanks for watching. Don't forget, favorite pet. Bye.